What's up everyone? In this video we'll be going over momentum and its conservation. We will start by defining momentum and the conservation of momentum. We will then go over equations of momentum, momentum conservation, and how it relates to force. Next we will talk about the three types of collisions. And lastly, we'll end off doing a practice problem involving momentum. When it comes to defining momentum, momentum is defined as the strength or force of something when it's moving. Basically, anything with a mass that is in motion or has a velocity has a momentum. If you look here, we have a pendulum. The ball that swings has the momentum, and it collides with the adjacent ball and transfers its momentum to that ball. Then that ball collides with the ball next to it and transfers its momentum. And this keeps on going until the very last ball. Eventually, the last ball has nowhere to transfer the momentum to, so it swings. And this repeats. Theoretically, a pendulum will continue to swing indefinitely due to the conservation of momentum. However, due to air drag and friction with every swing and collision, the ball loses a little bit of momentum until it eventually comes to a complete stop. Therefore, as we can see here, momentum in collisions is always conserved. Momentum of an object is equal to its mass in kilograms times its velocity in meters per second. Now, momentum relates to force, and as we remember, force is equal to mass times acceleration. Acceleration is just simply the change in velocity over change in time. So we can derive this equation from this one. Now if you look here, momentum, as we said, is mass times velocity, and we have mass times change in velocity here. What we can do is group them together and turn this into change in mass times velocity over change in time. And this gives us change in momentum. Newton's second law states that the net external force acting on an object is equal to the time rate of change of the object's momentum. Basically what this means is force is the rate at which momentum changes with respect to time. This equation down here is the equation used for conservation of momentum. The mass and the initial velocity of the first object plus the mass and initial velocity of the second object is equal to the mass and the final velocity of the first object plus the mass and final velocity of the second object. This equation is true in every collision. When it comes to collisions, there are three different types of collisions. There are elastic collisions, inelastic collisions, and perfectly inelastic collisions. Elastic collisions are ones in which two objects bounce off each other with no loss of energy. A great example of this is pool. One ball collides with the other, and the total kinetic energy is conserved. Inelastic collisions are ones in which two objects bounce off each other with some loss of energy. The energy can, for example, dissipate to heat. Therefore, total kinetic energy is not conserved. A great example of an inelastic collision is a car crash. Note that most everyday collisions are inelastic collisions. Perfectly inelastic collisions are ones in which two objects end up sticking to each other and moving with common velocity after the collision. This often results in the largest loss of energy. Therefore, total kinetic energy, again, is not conserved. The best example here is a car crash in which two cars collide and stick to each other and move at the same velocity. Though this is not realistic, the most common momentum problems involve perfectly inelastic collisions between two different cars. So let's go through the first question together. It says we have a 1,302 kilogram car traveling with a speed of 33 meters per second, which is about 75 miles per hour. What is the car's momentum? Well, we know momentum is equal to mass times velocity. And since we're given the mass of the car as well as the velocity of the car, we just plug it in and solve for momentum. Therefore, the momentum of the car is equal to 1,302 kilograms, which is the mass of the car, times 33 meters per second, which is the speed of the car. This equals 42,966 kilograms meters per second. This second question says, let's say the 1,302 kilogram car is now going 38 meters per second and gets into a collision with a stationary car that weighs 1,450 kilograms. Assuming that this is a perfect inelastic collision, what is the final velocity of the two cars? Remember that every collision has a conservation of momentum. And in a perfect inelastic collision, what happens is after the collision, so to start, let's list the equation for conservation of momentum. Next, I usually like to highlight the different parts of the equation they have given you. So they've given us the mass of the first car, the velocity of the first car, the fact that the second car is stationary, which means the velocity is 0, and the mass of the second car. It tells us it is an inelastic collision and asks us to find the final velocity of the two cars. What I usually like to do is fill out one part of the equation that we already know. They've already given us everything we need for the left side of the equation. The mass of the first car, as we said, was 1,302 kilograms, and the initial velocity of the first car was 38 meters per second, plus the mass of the second car, which was 1,450 kilograms, and the velocity, the initial velocity of the second car, which was 0 meters per second. Next, we'll try to fill out the right side of the equation. The masses are still the same, but we don't know the final velocities. Next, we'll try to calculate the left side of the equation since we have no variables there. We get 49,476 kilograms meters per second, which is the momentum. Since momentum is conserved, the initial momentum will be equal to the final momentum. Next, we'll add 1,302 and 1,450, which are the weights of the cars, on the right side of the equation since they have the same variable, which is the final velocity. We can then solve for velocity final. The final velocity is 17.98 meters per second. Just to give a quick recap, momentum is defined as the strength or force of something when it's moving. To find the momentum, it's the mass of an object multiplied by the velocity of that object. Force is related to momentum. We have 3 different types of collisions: elastic, inelastic, and perfectly inelastic collisions. Thank you, and I hope you have a great day.